Good afternoon, everyone. Uh, Today, I want to explain about the inorganic chemistry from second semester. Second semester chemistry, I want to explain, and in that uh, second semester inorganic chemistry P block elements, I want to take topic, and in that P block elements, already the important topics like diborane, different types of electron deficient compounds, and all we have learned in the previous class. Now for today's class, one of the topic from P block elements is interhalogen compounds. Interhalogen compounds. What do you mean by interhalogen compounds? Interhalogen compounds means halogens. What are halogens? Halogens means electronegativity atoms like fluorine, chlorine, bromine, iodine are called as halogens. Interhalogen means uh, one halogen is combined with other halogen is known as interhalogens. Remember that no same halogen will be combined. Two different halogens are combined. For example, iodine, fluorine, chlorine, bromine, iodine. So fluorine can combine with other chlorine or bromine or iodine also. Any other electronegative atom, but not the same fluorine. So there is a bond formation between the halogen, one halogen and other halogen forming to form a structure is known as interhalogens. So simple definition I want to explain is binary compounds formed by halogen among themselves are known as interhalogens. Binary compounds formed by halogens among themselves are known as binary. I already said that. One halogen, other halogen. Two. Two is nothing but binary. Binary compounds of halogens are known as interhalogens. Interhalogen compound. They have the general formula where AXN. AX down subscript you need to write N. N is nothing but number of uh, electronegative atoms. So AXN. So here in this N is equal to 1, 3, 5. See that it is compulsory odd number. So it never be even and it never starts with a 0. So N is nothing but 1, 3, 5 and 7. That means AX7 means AX means one halogen is A, other halogen is X. So this is about the interhalogen compounds. So interhalogen compounds definition I want to repeat once again. So binary compounds of halogen uh, forms a interhalogen compounds are known as interhalogen compounds. They have the general formula known as AXN, where N is nothing but 1, 3, 5. It will be odd numbers. So we'll go to the types of interhalogens. There are 4 types: AX type, AX3 type, AX5 type, and the fourth one is AX7 type. That means AX. AX means one halogen is A, other halogen is X. AX3, one halogen is A, other halogen is 3. X3. So 3 halogens. 3 same type of halogen. AX5, one halogen is A, uh, X5, other halogen is 5. X5. AX7, one halogen is A, other halogen is 7. So we'll go to the detailed examples of these. You can see these examples. AX type. AX type, for the first type is AX type. So examples are iodine fluoride, chlorine fluoride, bromine fluorides. You can see clearly that one iodine is combined with other halogen atom. Iodine is also electronegative atom. Fluorine is also an electronegative atom. So the combination of the two is called as one iodine fluoride. In the same way, chlorine fluoride also, and even bromine fluoride. It can form any of that. But coming to the next one is AX3 type. In AX3 type, chlorine trifluoride, bromine trifluoride, iodine trifluoride. So this is AX3 I said. One halogen is chlorine here, A type. X3 is F3, BRF3, IF3, like that. Examples. Coming to the next one is AX5. AX5 is A is one type of halogen. X5 is other type of halogen, that is chlorine pentafluoride, bromine pentafluoride, iodine pentafluoride. AX7 is IF7, iodine heptafluoride. So this is about the AX5 type. Coming to the next is AX7. One halogen is iodine and the other halogen is F7. So 7 fluorines. So here we'll go to the 1 type preparation, their structure, their bonding, their hybridization, their bond angles and all. We'll be learning each and every type in this topic. Coming to the AX type. First we'll see the preparation, then the bonding, structure and bonding, and uh, what is the hybridization we'll see in the this. Coming to the first one is preparation of AX type. So the compounds can be prepared by the direct union of two halogens. So you can take any two direct halogens and you can combine the two halogens like fluorine or chlorine or bromine or iodine or fluorine or any combination of two halogens you can take with electronegativity charge and you direct union. When you add one electronegativity atom to the other, when you add one halogen to the other halogen, you get a product as uh, combination of that is you get is X type form. So you can see the reaction here, Cl2 F2 giving rise to 2ClF, bromine Br2 F2 giving rise to 2BrF, I2 plus Cl2 giving rise to ICl. So if you see the structure, then direct union no. So therefore ICl means chlorine fluoride means chlorine fluorine. Chlorine will give one electron, fluorine will give one electron, and they form a bond that is called as a linear shaped bonding is formed in AX type. So now we'll go to the second one is AX3 type. So in this AX3 type, so simple, it may be prepared by passing a chlorine or chlorine monofluoride mixed with an excess of fluorine through a nickel tube which is maintained at 220 degrees centigrade. Take a nickel tube, maintain the temperature at 220 degrees centigrade, and that means it is which is a hot nickel tube, and this in this metal nickel tube what you do is you add a chlorine or chlorine monofluoride is to be added, and it is mixed with an excess of fluorine. So you need to add excess of fluorine. When you add an excess of fluorine, you, when you maintain the temperature as 220 degrees, you get the product as AX3 type. So we'll see the reaction of this AX3 type. So this is the reaction. So chlorine fluoride plus chlorine monofluoride, you are mixing with fluoride and you are passing through a nickel tube and maintained at 220 degrees centigrade, and you get the product as chlorine trifluoride. This means that AX3 type is formed. So we'll go to the structure and bonding of that. So coming to the structure of X3 type. So A is chlorine, X3 is fluorine trifluoride, F3. So here what you get is this is the chlorine atomic number. What you can see here in this picture, chlorine atomic number is 17, and this is the electronic configuration of chlorine: 1s to 2s to 2p 2p6 3s to 3p5. So chlorine excited state, if you see, one of the electron from p orbital will jump into the d orbital. That's why one electron is jumped from p orbital to d orbital. That's why instead of 3p5 it has got 3p4 and 3d1. If you see the electronic structure of chlorine atom excited state, so this is the 4 electrons and 1 electron here. So how many bondings are involved? sp3d. So sp3d hybridization, and the shape is, you can see the shape trigonal by structure. I will explain you how the bonding is formed. We'll see first. So in that sp3d is involved, so it is forming sp3d hybridization. Coming to the, how many in this, three lone pair of electrons are present. These three lone pair of electrons will combine with the three electrons donated by the three fluorine atoms. Those electrons will combine and forms a bonding, forming a T-shaped structure. This is a T-shaped structure, and two paired electrons are present here in this. This is sp3 as well as sp3d is involved in the bonding. It is called as sp3d hybridization. And the shape, if you see, it is trigonal bipyramidal. You can see three fluorines are present at each corner of this triangle, and in this you having a two uh, two pairs of paired electrons that will be lying above and below the triangle, and three fluorines are present. uh, that's why it is called as bipyramidal. Chlorine is present in the center, three fluorines are occupied at three corners of a shape, and this is two paired electrons will be lying upside as well as down. So here this is about the shape. I have given three different structures of ClF3. The reason for this forming three, it can be any form. So just like it is the resonating structures, it shows chlorine trifluoride will be formed in three forms. So only change in the position of the uh, chlorine and fluorine, and it's paired electrons also. So this is just the, so from microwave data, the structure of chlorine trifluoride is planar and T-shaped. Its bond angle is almost 90 degrees. Its bond angle is 90 degrees, and it is shown that it is T-shaped structure. It is a planar T-shaped structure. It's looking like T here. T, capital T. T for Telugu. T shape it is showing. This is about the AX3 type, second type. Now we'll go to the third type, AX5 type. So we once will see AX5 type. How it is spread. First we'll go to the preparation part. Next we'll go to the structure and bonding of that AX5 type. So for AX5 type, the example is, simple example is IF5, iodine pentafluoride. So it is prepared by passing fluorine over iodine in a heated quartz tube. Take a quartz tube, heated quartz tube, and you pass fluorine over iodine. Take a heated quartz tube and in heated quartz tube, you add pass iodine as well as fluorine. So you will get a product as, here you can see the reaction, iodine plus 5F2 giving rise to 2 moles of iodine pentafluoride. So we'll go to the, this is about the preparation of AX5 type. Now we'll see the structure and bonding of AX5 type. So coming to the structure and bonding. Structure, if you see, iodine 53. The atomic number of iodine is 53. You can see this electronic configuration 1s2, 2s2, 1s2, 2p6, 3s2, direct 53, no. So 2px, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p5. So now this is about the electronic configuration. Coming to the excited state. So in excited state 5p5 is there, 5s2, 5p5. So second excited state, 2 electrons will jump into the d orbital. As a result, p orbital is having 3 unpaired electrons, d orbital is also having 2 unpaired electrons. So totally 5 unpaired electrons are there. These 5 unpaired electrons will be combining with the 5 electrons of fluorine, forming paired. In that way it forms a bonding and giving the structure as square octahedral shape. And you can see the involvement is S is involved, P3 is involved, and D2 is also involved. So it is called as sp3 D2 hybridization. So you can see how many lone pair of electrons are there? Only one lone pair, that is in 5s2. So that lone pair of electron will be forming on the one of the position, that is called as, you can see the paired electrons down into the structure. So this is octahedral, or you can also call square pyramidal also. It is a square pyramidal. Upside fluorine, down one paired electron is present. This is about the structure. You see the structure. The structure is, it's a simple square pyramidal, and actually in this picture it is showing that it is an octahedral shape, but it is not an octa. It is an square pyramidal. Pyramidal means only one pyramid is present. That's why it is square pyramidal you call. If it is two, you will call it as bipyramidal. So this is about the structure and bonding of iodine pentafluoride, that is AX5 type. AX is over, AX3 is over, AX5 is over, AX7. Now the last fourth one is what we are going to learn is AX7 type. So in this AX7 type, the simple example is IF7. So iodine takes part in bond formation in the third excited state. So first excited state, one electron will jump into the d orbital. Second excited state, one more paired electron will jump into the d orbital, d2. And in the third excited state, one more electron will jump into the third 5d orbital. So here the involvement is sp3 d3 hybridization. So sp3 d2 is the previous AX5 type, but here sp3 d3 is the hybridization. Coming to the structure and bonding of this. So coming to the structure and bonding. You can see the structure of IF7 structure. See here, iodine is surrounded by how many fluorines? 7 fluorines. So 7 fluorines will give 1 electron. Totally 7 unpaired electrons given by 7 fluorines, and 7 unpaired electrons are present in the iodine. As a result, it will combine and forms a structure. That structure is known as sp3d3 hybridization, and the structure name is pentagonal by pyramidal shape. Pentagonal, this is an octahedral shape. The structure name is different here, wrong here. It's not an pentagonal bipyramidal, it is octahedral shape. So with this we have finished the interhalogen compounds. So simple classification is, how many types are there? uh, this is the interhalogen compound. Binary compounds of halogens combined with other halogens is known as interhalogens. The formula is n is equal to 1 3 odd number. So there are 4 types: AX type, AX3 type, AX5 type, and AX7 type. And coming to the AX type, chlorine fluoride, you can take example. It's a linear shape, and it is a linear shape, AX type, and it is simple preparation. What we have in direct combination of that, you will get a AX3 type compound. Coming to the second one, AX3 type, by passing chlorine monofluoride with fluorine through a hot nickel tube, you will get a combination of, you will get a chlorine trifluoride preparation. So this chlorine trifluoride, after it is forming, how it is structure and bonding we have seen. So it is a T-shaped structure. It is sp3d hybridization. So sp3d hybridization, its shape is simple trigonal bipyramidal. So two paired electrons will be present upside and down. So it is called as trigonal bipyramidal. Microwave studies shows that it is a T-shaped, planar T-shaped structure. Coming to the AX5 type, so in this, iodine pentafluoride is taken as example. In that, iodine atomic number is 53, and outermost electron configuration, if you see it, iodine has uh, two unpaired electrons in the uh, two. It will undergo two excited states. First excited ground state, electronic configuration. First excited state, one of the electron will jump into the d orbital. The second excited state, one more electron will jump into the second orbital. In that way, there is a formation of 5 unpaired electrons where sp3d2 bonding is involved, and the shape is uh, square planar shape. Coming to the AX7, this is octahedral square pyramidal, this is, and this is octahedral shape. Here also you can take simple example as IF7. IF7 is forming octahedral structure, and 7 fluorines are present at 7 corners and forming octahedral shape. So in this S third excited state, that is, there is no third excited state, that's why the s orbital pair of electrons will jump into the d orbital. As a result, totally 7 electrons are present. 7 unpaired electrons are present, and these 7 unpaired electrons will combine with the 7 electrons of fluorine, and they form a octahedral structure forming sp3d3 hybridization. This is about the interhalogen compounds what we have learned in today's class. I hope you all understood this class, and this is very important for the examination point. They are going to ask compulsory in the final exam. So how will be the question means, What are interhalogen compounds? Explain the types of interhalogens with explain the structure and bonding of interhalogens, or give the preparation, structure and bonding of interhalogens. Like that also you may get the question. So preparation part, structure and bonding part is very very important for the examination point. So with this I conclude this topic. So we'll take we'll start the video with another topic in the next. Thank you one and all.